welcome back to the Backyard Professor Math videos. We are continuing our odyssey, as it were, indubitably, into linear equations. We're discovering that we are smart enough to do these. They really aren't that difficult because once you understand the operations, the size of the numbers are irrelevant, the kinds of numbers are irrelevant completely, and that's real nice, right? So, we get a little bit more complex, but not difficult. To review, we have two operations that's been done to our x. They've multiplied a 3 and they've added a 2. We undo those by subtracting the 2, which equals 10, and dividing the 3, which equals 10/3. And there's your answer. Or if you want a mixed numeral, 3 and 1/3, because 3 goes into 10 3 times, there's 1 left over and you have 1/3. It's that simple. Negative 5x minus 6 equals 16. It's the same principle here. Someone has come along and multiplied a negative 5x and subtracted a 6. We want to isolate the x. How do you isolate the x? You add the 6, and that gives you 22, and then you divide by the negative 5. And there's your answer, negative 22/5. If you want to put it into a mixed number, you divide the denominator into the numerator, so that's going to be a negative 4 and 2/5. That's the mixed number as opposed to the fractional equivalent. It's that simple. If you have half h plus 3 equals 1, it is the exact same principle. Someone's come along and multiplied a half to our h and added 3. How do we isolate the h? We subtract 3. So now we have 1/2 h equals 1 minus 3 is negative 2. And then to isolate h, we multiply by the reciprocal of 1/2, which is 2/1, or just 2, times 1/2, h, equals negative 2 times 2, which is negative 4. And our answer becomes negative 4 to that. It's that simple. Someone's come along and we have a negative 18 minus m equals negative 36. Now this is written a little bit differently. Instead of the variable being multiplied with something, the variable itself is subtracted. So what do? Well, we have a negative 18. We know that's the same as subtraction. How do we know this? If we keep the signs together of the numbers, this is very critical, we can exchange their order that they appear. So that this is really negative m minus 18 equals negative 36. Now we can isolate m, add 18. Right? Which is technically, and again, keeping the signs, we can switch these so that we see this is a subtraction. This is 18 subtract 36. What's the answer to that? 18. But it's going to be a negative 18. Well, I didn't write that very well, did I? It's going to be a negative, that's more clear, a negative 18, right? But it's still negative m equals negative 18. We don't want a negative variable. The negative is an implied negative 1, so we divide by negative 1 on both sides, and a negative divided by a negative is a positive 18. And when we see that a positive 18 that has been a negative minus an 18, which is a plus negative. A negative 18 and a negative 18 does equal negative 36. So we can check our work as well. That's nice how that works. The more we learn, we want to maximize our mathematical knowledge and prowess, and intellect, and intelligence, and IQ, yada, 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 on and on and on. However, we do want to maximize our knowledge because that gives us better power to solve real-world equations. Negative 2 minus 4x equals 18. We add 2, which equals 20, and then we divide by negative 4, which equals x. That isolates our x. X equals negative 5. Okay? Now what happens? Again, we're going to give it a little bit more complication. We're going to tweak it just a little into a little more complication. Not difficult, just more complication. And you'll begin to see that complicated doesn't make it impossible. It just means we have an extra step. What if we're told that 4x plus 2x equals negative 12? Now we have two numbers with a variable each. But notice, these x's have the same power, which, if you remember, is the definition of a like term. These are both x to 1. Any variable that doesn't have a power number up in that little right-hand corner is assumed to be 1. It's just itself. Those are like terms, so we can add them together. So what's 4x and 2x is 6x equals negative 12. How do you get x alone? You divide by 6, divide by 6. 6 into negative 12, a positive into a negative. There's only one negative, so you know it's going to be negative. It's negative 2. See, a little bit more complicated perhaps, but not more difficult. Really, that wasn't that hard. Let's do another one. Let's say 3x minus 3 equals 2x plus 2. And now you're starting to freak out. You're saying, yeah, see, dude, here it comes. Algebra, you're lying your butt off to us. Algebra's harder than all get out. No, 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 no. True, we have a variable on either side of the equal sign, and we also have a subtract 3 and a plus 2. But watch. It's a matter of collecting like terms through the orders of operations that we already know how to do. Watch. It's easy. First, subtract 2x and get your variable on the same side. How do you get 2x over here? It's added here. It's positive 2x here. So 2x minus 2x will get rid of the x on this side, right? So if you add 2x to this side, or you subtract 2x from this side, you have to subtract it from that side. Okay? So this ends up being 3x minus 2x minus 3 equals, we've canceled out that 2x, there's only a 2 left over. Then we put the operations together. What is 3x minus 2x? It's just x. It's 1x, right? We can leave off the 1 and just write x minus 3 equals 2. Now you recognize this real easy. How do you get rid of 3? The negative 3? You add 3. If you add 3 to this side, you add 3 to that side, and x equals 5. You see? A little more complicated, but not more difficult. Let's do another one of these. Let's do another one of these kind, because we will run into these enormously in all kinds of word problems. So it's good to get used to them now. 5y plus 5 equals 10y plus 2. Again, we have the situation where each side has a variable and each side has a numerical coefficient. Well, what do? You want to put the y on one side or the other. It really doesn't matter which side of the equation you put that y, but you do it by the inverse operation. You undo. 10y is positive here. The way to get 10y over to this is to subtract 10y, right? So if you go 10y minus 10y, don't forget you have a plus 2 here. 10y minus 10y is 0, but you subtracted 10y here, so you have to subtract 10y here. So we have 5y minus 10y, and don't forget you have a plus 5. Plus 5 equals 0 plus 2. Isn't that cool how that works? Well, what's 5 minus 10? Negative 5y equals, we're going to get rid of this 5 by subtracting it over to here, right? 2 minus 5 is negative 3, right? You want the y isolated, you have a negative 5 multiplied to it, divide by negative 5, divide by negative 5, a negative 5 and a negative 3, the negatives make this positive, so this is simply 3/5. Not that complex, is it? Let's do another one of these. Let's say we have, I probably write way too big, huh? Whoop. 3y minus 1 equals 4y plus 2. We want to put the y's on the same side, right? So let's subtract 4y from here. So this is going to be 3y minus 4y minus 1 equals 2. We just subtracted 4y from here and subtracted 4y from there. Subtracting 4y here got rid of it, so we're only left with this 2. Now it's over here. What's 3y minus 4y? Is minus 1y, right? Or just minus y. Minus 1 equals 2. We want to get rid of the 1, so we add it. Add 1 to here, and it gets rid of it. You add it to here, and it turns it into 3. So now we have negative y equals 3. We don't want a negative with an exponent, though, or with a variable. So, and that's a negative 1, so we divide by negative 1 there. We divide by negative 1 there. Negative 1 into positive 3 is negative 3. A negative into a positive is a negative. And that's how that works. Not too complex. A little bit, not too difficult, I should say. A little bit more involved. There's a couple of extra steps that we have to do now, but that's okay. We know how to do them. We already know how to do the operation, so it's really not more difficult. There's just a couple of extra steps. I want to beat that into your heads because linear equations are not difficult. We are smart enough to do this. It's just a matter of understanding the operations. 8a plus 3 equals 11a minus 6. Same principle. We want to get the a on the same side of that equal sign together. How do we do that? By doing the opposite of what it is. Now this is a positive, and this is a positive. We don't normally write the positives on there. But in order to get the 11a over here, we have to subtract it. That cancels it. That leaves us with negative 6. But we have 8a, we subtracted 11a, they're like terms, plus 3. Now this side equals negative 6. 8a minus 11a. 8 minus 11 is minus 3a, because we have the variable, plus 3 equals negative 6. We want to get rid of the 3 because we're trying to isolate the variable a, right? So we subtract the 3 because it's added over here. We subtract the 3. Subtraction is adding the negative. So this is negative 6 plus negative 3 is negative 9. Now we've gotten rid of the 3 here. We have negative 3a equals negative 9. We want to isolate the a. Negative 3 has been multiplied to it, so we divide by negative 3. Negative 3. What we do to this side, we do to this side, negative 3. Negative 3 into negative 9 is positive 3. And there's your answer. Because the negatives dividing here canceled, this turns that into 3. That's how it works. Let's do another one. 1/2 x plus 5 equals 3/4. Oh, I can see right now. I'm going to have to erase this and do it over here. This one gets involved, but I'm going to show you a really cool trick here. How's my time doing? Oh yeah, I'm in good shape time-wise. Okay, this is a fun one. It gets a little involved, so I'm going to show it to you. 1/2 x plus 5 equals 3/4. Now this is typical linear equation style format. This is so beautiful for linear equation. What is the common denominator of those fractions? If we can, we want to eliminate fractions altogether out of the linear equations. We do that by multiplying by the number that's the common denominator. So what we want to do here is multiply both sides by 4, because that's the common denominator that these fractions are going to end up as, right? So we multiply this side by 4 times 1/2 x plus 5 equals, we multiplied this side of the equation by 4, so we multiplied this side of the equation by 4 times 3/4. Right? Now remember our distribution. We distribute this 4 into this term and this 4 into that term. So let's do that. 4 times 1/2 x equals 4/2 x. 4 times 1 is 4, and you leave the denominator alone. Because technically 4 is 4 over 1, and you're multiplying a fraction by a fraction, right? So that's 4/2 x. But what is 2 into 4? That simply becomes 2x, doesn't it? So we've turned our fraction of 1/2 x into 2x, plus we distribute this 4 with this 5. What's 4 times 5? Plus 20. Equals, now 4 times 3/4. This is 4 times 4 over 1. You simply multiply across. 4 times 3 is 12. 4 times 1 is 4. What's 4 into 12? 3. So that's what that becomes. It equals 3. And now we have an equation very similar to what we're used to doing. We want to get rid of the 20 by subtracting it because it's been added. 3 minus 20 is negative 17. Now we have 2x left over equals negative 17. How do we get rid of the multiplied 2? We divide it by the 2. What we divide on that side, we have to divide on this side, and the answer is negative 17 twos. If you need to make it into a mixed number, 2 goes into negative 17, negative 8, and 1/2 times. It's that simple. That's how to do these. That's a linear equation there. That is really kind of nice. And I do want to, well, I've got time, I think. I'm going to hustle here. I want to do one more of these because that looks pretty complex and involved, and it is only because we have so many steps to do. It's not really any more difficult because we know what we're doing with the fractions. Let's say we have 2/3 x minus 1/6 plus 1/2 x equals 7/6 plus 2x. You look at that and you go, holy nightmare Batman, what are you doing to me, Schertz? You're spreading my brain into spaghetti. No, relax. What is the least common denominator of all these fractions? Everything's going to go into 6. So that's the number we multiply by each side of the equation is 6. So we want to multiply this by 6, 2/3 x minus 6 times 1/6, multiplying it by that term, plus 6 times 1/2 x equals 6 times 7/6 plus 6 times 2x. Wow, that's a lot of multiplying, but watch what this does. It is so beautiful and easy how this works. You're going to love this. 6 times 2, remember, 6 is 6/1. You're simply multiplying 6/1 times 2/3. You multiply the numerators across and the denominators across. Don't worry about common denominators. We've already done that. Now we're multiplying each term separately by 6, right? So this is 12/3. 6 times 2 is 12, and you don't multiply the 3. The 3 times 1 is 3. 12/3 x minus 6 times 1 is 6, and there's your denominator, because this is 6/1 in reality. 6 times 1 is 6, 1 times 6 is 6, plus 6 times 1 is 6, and 1 times 2 is 2x. Don't forget your x, equals, this is 6/1, 6 times 7 is 42, over 1 times 6 is 6, plus 6 times 2x is 12x. And look how we've eliminated the fractions. And you say, wait a minute, dude, I see nothing but fractions. Watch! 3 goes into 12 4 times. That's simply 4x. 6 goes into 6. We minus 6/6 is 1, plus 2 goes into 6 3 times. We've got the x, equals 6 goes into 42 7 times, plus 12x. Now it's just a matter of collecting the like terms, adding, subtracting, and putting it all together. Piece of cake, isn't it? 4x plus 3x. These two are like terms. That gives you 7x minus 1 equals 7 plus 12x. You'll want this x over there. How do you get it over there? You subtract it. So we subtract it, it eliminates it over here. This is 7x minus 12x minus 1 equals 7. We got rid of that 12x on this side and put it over there. 7x minus 12x is negative 5x. We have a negative 1. To get that negative 1 over to here by this 7, we add 1. So that becomes equals 7 plus 1 equals, I'm going to write it up here, 8. We have a negative 5x equals 8. We divide by negative 5, we divide by -5. The answer is -8/5. One step at a time. Each operation that we already know how to do, that looks like a great big huge conglomeration of a mess, because I've taken it one step at a time with you to show you how to systematically solve what is supposed to be a very complex linear equation, but it's not. It's just fractions, and that's how to handle fractions. Anyway, let's see. I've got about, nope, I don't have time. Darn it, that's too bad. I wanted to do one more of these, but I don't have the time. So just realize that through practice, through familiarizing ourselves, through getting used to it, you don't start in life doing 1,600 push-ups, right? You work up to that huge number of push-ups. That's how many push-ups I did in 2 hours in my younger days. 1,600 of them. That took a lot of work, but it took me 8 months of working out to where I got to where I could do 1,600 push-ups. I did push-ups every day. Same thing with math. We work the math equations every day. Look, if all you can do is 10 minutes, give yourself that extra 10 minutes. It adds up to experience. It adds up to knowledge. It adds up to where when you see an equation like this, you no longer say, I don't have a clue, I don't know what to do. Now when we see an equation like this, we say we know exactly what to do. It's adding, subtracting, so we know we have to have common denominators. We find the common denominators, then multiplied by the least common denominator to eliminate the fractions. Then we simply collect like terms, add and subtract like terms, and come up with the answer. Yeah, it takes several steps, but it's not impossible. It's not hard. You just have to take the time to systematically solve the equation. And it's possible. That's the great news. So anyway, that's enough lecture today. Holy cow, I'm a motor mouth today. I've been trying to go fast so that we can crunch a lot of numbers. Now I think we're getting to the point to where I'm going to begin showing you how to graph the linear equations. And this is one of my favorite parts of algebra. This is fun. In calculus, we're going to be doing a lot of graphing of equations, all kinds of equations. Linear equations, nonlinear equations, polynomial equations. We'll have thousands and millions and billions of different functions to graph. We'll learn all about that, I promise. So anyway, hey, happy calculating, man. Have a great life, and I will see you in the next video. Oh, absolutely.